10. Let's recap. In our last class, we discussed image formation by concave mirror. That is in your chapter 10, light, reflection and refraction. Today we have taken a topic, image formation by a convex mirror and uses of spherical mirrors. Okay, let's start. There are two cases. Now you look at the display board. In the first case, this is here the object is at infinity. Okay. Now you see Mn is a convex lens. Why? Because this is outward curve. The outward curve portion or curved surface is called the reflecting surface. Okay. And the rays, all rays parallel to the principal axis. Here, principal axis, after reflection, here you see is reflected. This is the reflected ray. After reflection, okay, appears to have come from a point on the principal axis, that is called focus. Now you see, so is another ray parallel to principal axis. After reflection, okay, this is called incident ray, this is called reflected ray. Here this is called incident ray and this is called reflected ray. After reflection, appears to have come from the point on the principal axis, that is called focus. And you see, the focus is behind the mirror. This is virtual focus. Now see, the image is formed at focus. So image is formed at focus. When object is at infinity, the image is formed at focus. Now V for virtual, and it is formed behind the mirror. Okay, that cannot be captured on a screen. Then E for erect, that is not inverted, that is erect, this is inverted. So erect. And D for diminished, and size is point sized. Okay, so these are the nature of the image formed by convex mirror. When the object is at infinity, the image is formed at focus. This is the case number 1. So let's come to the case number 2. So here Mn is a convex mirror. The outward curved surface acts as the reflecting surface and the inward surface is opaque. Okay. Now see AB, the object, at a definite place means the PB distance is a definite distance, it can be measurable. Okay. It can be measured, it is measurable. Okay. So now you see the ray parallel to the principal axis, after reflection, appears to have come from the point here focus. And now look at the ray directed towards the center of curvature. It returns after reflection, it returns back along the same path, and it appears to have come from the center of curvature. So the intersecting point is A, and the perpendicular AB is called the image of AB. So image, when the object is at definite or finite distance from the pole, the image is formed between pole and focus. Now you see pole and focus means behind the mirror, that is virtual. So the image is formed behind the mirror means it is virtual. We cannot capture the image on the screen. Then you see, look at here, AB and AB, not BA. So the image is erect but diminished, short. As compared to the object, it is short or diminished. So these are the nature of the image formed by a convex mirror when the object is at a finite distance and the image is formed between pole and focus. So now the case number 2 and case number 1 we discussed. So come to the uses of spherical mirrors. We discussed two kinds of mirrors. One is concave, another is convex. In concave, you see concave, this is inward surface after the reflecting surface. Now look at here. So when this surface is called outer surface, when outer surface acts as the reflecting surface, it is called convex mirror. So we have discussed about two types or two kinds of mirrors, the concave mirror and convex mirror. So let's discuss their uses. So we have highlighted the points only. In headlight, in a vehicle headlight bulb, the vehicle headlight, that not bulb, vehicle headlight, concave mirror is used. Why? This is the case number 5. To satisfy the case number 5, you remember, you recall, when the object is at focus, so the parallel with the object, the image will formed at infinity. So the parallel beams of light, the parallel rays of light, a beam of parallel rays of light will emerge. Okay. So for that case number 5, it is used in headlight. Similarly for torchlight, to generate a beam of rays or to produce a beam of rays, parallel rays. In searchlight, that actually hunters they use, and to search something at night we use that light. So in that light we also use concave mirror due to the principle of case number 5. The object is at focus, the image is at infinity. Just vice versa of case number 1. Okay. Come to the point number 2, that is using shaving mirror and dentist mirror. Right? And this satisfies. This is based on the principle of case number 6. When the object is placed between pole and focus, okay, the image is formed behind the mirror. This is an exception case in case of concave mirror. And you see the the image is here, enlarged, virtual, and erect. Okay. So in shaving mirror, we can view the larger face, and dentists can view the larger image of the teeth and the mouth portion. Okay. So the two uses are based on case number 6. You please refer your textbook. And in solar furnaces, large concave mirrors are used to generate heat. Okay. So it satisfies, it is based on the case number 1. Okay. Or when the object is at infinity, all parallel rays coming from the sun, they after reflection they converge. They converge and meet at a point that is called focus. That's why concave mirror is called a converging mirror. And at that point, at point focus, heat is generated. And you can do it, means taking a small concave mirror and projecting the focus on a plain paper. After some time, the heat will be generated and the paper will start burning. So these are the major uses of concave mirror. So come to the next side, that is convex mirrors. So in a convex mirror, this case is very important. For this principle, when the object is at finite distance from pole, the image is formed between P and F, the nature of the image is erect, short and virtual. So it is called a rear view mirror. In all vehicles, the convex mirrors are used to view the rear objects and the traffic behind the vehicle. It can be visible through the convex mirrors fitted in the vehicles. So vehicle side mirror. So even in a bike or actually in four wheelers, you might have seen two mirrors are fitted on both sides. So it helps the two mirrors, they help the driver to see the traffic behind the vehicle. But the particular image means the driver can see the complete image, the total image of the traffic behind the vehicle. A large bus, a tall tree, even a tall tree will be seen as a short tree. But the complete and total image would be seen by using this convex mirror. So you see the reflecting surface is outward. So the outward curved surface, it has an advantage. Advantage means the image for the wider coverage, from the wider coverage, the widest coverage field, the image could be seen through a convex mirrors. It is an advantage of this convex mirror than plane mirrors. If actually there will be a question, why don't we use plane mirrors to see the rear views? In plane mirror, we cannot see the image, complete image, and the image is erect, virtual, okay, but the complete view of the image or of the traffic cannot be seen through the plane mirror. And the outward curved surface makes a field, means gives a wider coverage of the field for furnishing the image. So at Agra foot in the wall, a large convex mirror has been fitted. Why? And it is projected towards Taj Mahal. So looking at the mirror, the viewers, the tourists, the travelers, the visitors, they could see the complete image of Taj Mahal due to the principle of the image formation in case number 2. A complete view of Taj Mahal could be seen by the convex mirror fitted in the wall of Agra Fort. So whenever you visit, you please experiment it. You please check it. You please observe it, and you please watch it. Okay. So these are the major concepts of image formation by a convex mirror, and we have discussed 6 cases of image formation by a concave mirror. Now we discussed the different uses of concave mirrors and convex mirrors. Okay. Thank you. In our next session, we shall discuss the sign convention, means what sign, whether plus or minus sign, used to calculate the image distance or object distance, and we shall derive the mirror formula and magnification of the image. In next class we shall discuss. Stay tuned to watch our next video. If you like, you may subscribe our channel to watch our series of pedagogical videos based exclusively based on textual materials. Thank you all for watching.